today's session we are going to discuss about lexical analyzer generator. That means here we are going to make use of a tool called as Lex tool. Lex is a program which takes source program as input and generates stream of tokens as output. Okay, this Lex tool will work together with YAC parser generator. Okay, so in the lexical analysis phase, we'll make for generating the stream of tokens, we'll make use of this Lex tool. So that in the lexical analyzer will have a Lex specification file. So that will be extended with .l. So we'll write a Lex specification file in Lex language. So that that will be extended with .l. Then that will be given to the Lex compiler so that it will generate a C program as output. That C program will be given to the C compiler so that it will generate a.out file. So whenever we are writing a Lex specification file in Lex language according to our requirement, that will be given to the Lex compiler so that it will generate a C program called as lex.yy.c. And that C program will be given as input to the Lex C compiler so that it will generate an executable file called as a.out. That for that executable file, if we give our source program as input, and then it will generate stream of tokens as output. Here, see, in the lexical analysis phase, we will write a Lex program in Lex specification language. Okay, so and that should be extended with .l. So that has to be given to the Lex compiler so that it will generate lex.yy.c as output. So this is the output of Lex compiler. First, we'll write according to our requirement whatever the instructions we are given with. So according to our requirement, we need to write a Lex specification file. For that Lex specification file will be given to the Lex compiler. Then it will generate lex.yy.c as output. So as it is extended with C, it is a C program, so that should be compiled with C compiler. Then it will generate an executable file called as a.out. So for this a.out file, we need to give our source program instruction, that is input stream as input, so that it will generate sequence of tokens. So when we want to make use of this Lex tool, we need to know how we are going to write the Lex program. Okay, so here we are having some set of rules for writing a program in Lex language. So this Lex program is actually divided into three parts. One is the declaration section, and second one is rule or condition section, and the third one is procedure section or procedure or subroutine section. So in the declaration or definition section, we need to define or we need to declare whatever the header files or whatever the variables we want to make use in our program. Whereas in the rule section, we need to specify our conditions for specifying the tokens. What type of token, if the given input string is in this format, then what type of token it is, that has to be specified in the rule or condition section. So here, if it satisfies the given condition, then what type of action to be taken has to be specified in the rule section. Whereas in the user subroutine or in the procedure section, we need to specify the functions. So in this subroutine section, the main function is y/lex function. Whenever y/lex is automatically called whenever a stream of tokens has been given as input to the Lex specification file. So this function will identify what type of token it is. This is the main, by making use of this Lex function, y/lex function only, we are going to execute the rule section in the Lex specification file. So first, how we are going to write the Lex program as well as how we are going to run is, first we need to describe what the lexical analyzer generated by the we need to describe what type of tokens we are going to generate by using this Lex specification file in the rule section, and then for executing those rule sections, what are the variables or identifiers we require, and that those has to be specified in the declaration section. So first, the Lex specification file has been generated by the lexical analyzer, and that will be extended with .l. So file name .l, we need to specify file name .l. So in that we are having three parts. One is declaration section, rule section, and then procedure section or subroutine section. So in the declaration section, we will mention the identifiers or any declarations or here we need to mention any declarations like preprocessors or else any identifiers we need to mention, whereas in the rule section we need to mention the whatever how we are going to consider what type of token it is, or what are the, if the rule has been satisfied, then what are the operations we are going to perform. So how we are going to differentiate the rule section as well as declaration section and procedure section is here. Here the rule section has been specified by making use of these symbols. Sorry, this is the declaration section. So in the declaration section, we need to mention all the declarations in between these symbols, and whereas the rule section has been specified in between these symbols. So here, and after completing this rule section directly, we can mention the subroutine section. So first, the Lex specification file has been started with this symbol ampersand, then, and it will be so that we'll start with the declaration section, and the declaration section will be ended with these symbols. Then again we'll start with the rule section, and we should write the rules here. If rule 1 has been satisfied, then what are the operations we are going to perform, or what is the action we are going to perform, that has to be mentioned over here. Like this, we can specify any number of rules in the rule section. If the condition or the rule has been satisfied, what is the action we are going to perform, that has to be specified. Then after completing this rule section, we can write the subroutine section. In this subroutine section, we should start with main, and then Lex is the main function in the Lex program. So for executing the all the rules which has been specified in the rule section, we need to call Lex function. Here, whenever we have specified a Lex specification file, the Lex function is automatically called, so that this Lex function automatically go to the rule section, and it will execute the each and every rule which has been specified in the rule section. So here we'll go with some examples so that we'll understand what is what. It is a sample C program, or sample Lex program to count number of words in a given statement. Okay. So here we have declared two header files, that is hash include stdio.h and string.h. These header files are that means in the given we are given the string, so that we can make use of some string handling functions, and we should make use of all input output functions, so that we are including these two header files. Then we are for counting purpose we are declaring a variable called as I. Okay. So here how we are going to count the number of words, so that to count the number of words in a given statement or in a file, if the words are separated with a white space or a tab space or a new line character. So that here we are writing. So this is a declaration section. In this we are declaring, and in the rule section we are declaring. We are specifying whether the string may contain or the word may contain alphabets or digits, so that we are incrementing if the count value is more, even though the count value is small, so that we are incrementing the count value. So here the number of characters, whatever the number of characters, If we are having a word, then we are incrementing the word count. Then we are and after that we are printing the I value as number of words in the given file or given statement. And then we are calling y main function. In the y main function we are calling y lex. So this is the main function in the lex specification file, so that if we execute this, if we call this particular function, then it automatically go to the rule section. Here this will be work as like we have written A to Z or 0 to 9 star. So already in the previous subjects like automata theory, we have already known about star operation, that is clean closure operation, where if A star means 0 or more occurrences of A. In the same way, here we are taking A to Z or small a to Z or capital A to Z or 0 to 9. So, if we are having a single A, then it is one occurrence, single A star, or else capital A star. So, here we are taking only one occurrence. So, here if we are having any of the occurrence, then we are considering, suppose if it is count. This count can be, if we take count, so this C will be in this, in between, in the lowercase letters A to Z, and then O, again in this only, U, N, T. So like this, we are going to take this star means 0 or more occurrences, so that either 0 or more occurrences, so that we have taken 5 occurrences of this A to Z, the range in between A to Z, lowercase letters we have taken, and if this has been encountered, so that we are incrementing I value. So whenever a white space has been encountered, up to that we will read the character by character, and whenever white space has been encountered, we will increment the count value, so that the word count will be incremented by 1. So that at the end we are going to print the I value. So here first we will call every program execution starts from the main, and in the main function we are calling y/lex function. This y/lex function will take care of the rule, whatever the conditions we have specified in the rule section, and those will be executed. So according to that it will be executed. Okay.